64 to the a plus 125 to the b equal to 10. 16 to the a plus 25 to the b equal to 7. We want to find a and b. So first, if we pay attention, we will see that 64, 16, both of them are powers of 4. Also, we can say powers of 2. 1 to 5, 25 also powers, there are powers of 5. But if if you see, for example, 1 to 5 is 5 cubed, 64 is 4 cubed. So we can say 64 is 4 cubed. The a plus 1 to 5 is 5 cubed to the power of a equal to 10. Next one, 16 is 4 squared, so we can write 4 squared. A plus 25 is 5 squared to the b equal to 7. Now, by power rule, we can say x to the power of m to the power of n equal to x to the power of n to the power of m equal to x to the power of m. Okay? So you can switch m and n. So we can switch here 3 and a, 3 and a. So we can conclude what? 5, 4, sorry. First one, 4, the a cubed plus next one, 5 to the a cubed equal to 10. And next one, again, we can switch a and 2, 4 to the a squared plus 5 to the a squared equal to 7. So here, we'll replace 4 to the a with c and 5 oh, sorry. Here it is b, so I should change them to b. So it is b. So 4 to the a equal to c, 5 to the b equal to d. So we can say 3c cubed plus d cubed equal to 10. And next one, c squared plus d squared equal to 7. Okay. When we see something like this, there are lots of ways to solve this problem. One way is to use Newton's sum. One way is to use changing variable. Let me tell you one way. We consider c plus d, sum of them s, c times dp. Okay. Now let me erase this part. So c cube plus d cube, we want to write these two equations in terms of s and p. So the first thing you should know is that x plus y cube equal to x cube plus y cube plus 3xy. You should memorize this identity, xy. So we can conclude x2 plus y cube equal to x plus y cubed minus 3xy times x plus 1. If we apply this in first one, c cube plus d cube is c plus d cube minus 3cd times c plus d equal to 2. C plus d cubed is s, c plus d is s, because sum is s cubed minus 3 es equal to 10. And then we want to calculate c squared plus d squared. C squared plus d squared, again, you should memorize this identity, that's c plus d squared minus 2cd, c squared plus d squared, so we can say c plus d squared minus 2cd, which is this one, using this identity equal to s squared minus 2p equal to 7, okay? So let's write it here, s squared minus 2p equal to 7. Okay, from this equation, I want to solve this. One important way is to use replacement from here. You can say s squared minus 7. I take 7 to left hand side, negative 2p to right hand side is 2b. So I can conclude p equal to s squared minus 7 all over. I call this one star. In star, I replace p with this. So I have s cubed minus 3. Instead of p, I write s squared minus 7 over 2 times s equal to 10. Okay. Now we multiply both sides by 2s cubed minus 3s squared minus 7 times s equal to 20. Okay. If we simplify, here we have 2s cubed and minus 3s squared minus 3s cubed plus 21s equal to 20. If you take all things to left hand side, will be 2s cubed minus 3s cubed. It will be negative s cubed. Okay. 2s cubed minus 3s cubed negative s cubed plus 21s. And we can take this 20 to left hand side minus 20 equals. Now we multiply it by negative 1. It will be s cubed minus 21s plus 20 equal to 0. Now because the degree is 3, we try to find at least one answer. If we try to find at least one answer here, we will see S1 works. Okay. Because 1 minus 21 plus 20 works. So you can factorize. And one factor is s minus 1. Because of we're creating s cubed, s squared minus s squared is s plus s squared minus s minus 20 equal to 0. And here we can factorize this, so it will be s minus 1. In this part, s plus 5, s minus 4 equal to 0. Okay, so s can be 4, can be 1, can be negative 5. And p is s squared minus 7 over 2. P is s squared minus 7 over 2. P is what? 16 minus 7. 9 over 2. For the next one is 1 minus 7 minus 6 over 2 negative 3 negative 5. 25 minus 7 18 over 2 9. What? Yes, and P are what? C plus C. C was what for today? We know at least 0. A and B are real numbers. So you can say S and P are at, we can also say it is positive because for today the diagram will be something like this for today in terms of this increasing positive, also 5 to the B. So we can say they should be greater than 0 S and P, some of them. Now let's check this one. Here plus the S, C plus D4. CD is 9 over 2. From this part, D is 4 minus C. If we replace it here, C times 4 minus C equal to 9 over 2. We can multiply both sides by 2. If we multiply both sides by 2, then 2C 4 minus C equal to 9. Now it will be 8C minus 2C squared equal to 9. Now we take all things to right hand side, 2C squared minus 8C plus 9 equal to 0. And okay, here it is, we should use quadratic formula. Quadratic formula is what? Let me write it here. If ax squared plus bx plus c equal to 0, then if x is real, delta or discriminant, which is b squared minus 4ac, should be at least 0. Here we know c is positive real numbers, and because it is a real number, delta or discriminant here should be negative 8 squared minus 4 times 2 times 9, which will be 64 minus 4 times 8, 72. It's negative 8 and it is less than 0. So contradiction, it's not possible here. So we prove there is no answer for A and B. Okay. If you have questions, send message to my WhatsApp number and please don't forget to subscribe. Turn on the bell and like the video. Thanks. See you next time. Bye.